next speaker will be Gustavo Lozano. He's going to talk about ICANN SLA monitoring system, the SLA.
So hi, Gustavo Lozano, Technical Services. As Alan mentioned, I'm going to talk about the SLA monitoring system, or as we call it internally, the SLAM. So this is the agenda for this presentation. Let's start. So why ICANN is monitoring GTLDs? So if you operate a new GTLD, you will notice in your agreement that there is a section called Specification 10. And that specification basically details all the technical requirements and service level requirements that you need to comply in regards to the operation of your services. So ICANN, we develop a monitoring system to verify that you are in compliance with those service level requirements. So if you go to this specification 10 in your agreement, you will notice that there is a table, and the first table that you will notice is what we call the service level agreement table. So basically this table details on a monthly basis what are the service level requirements that you need to comply in regards to DNS, RDDS, and EPP. This is like a normal type of service level agreement that you will have with your ISP, for example, in regards to the service that they need to provide. And if you go further in that specification, you will notice that there is a second table, which is this table that you have here. And this is what we call the emergency threshold table. So basically, within that specification, it says that we have some emergency thresholds, and if you reach those emergency thresholds, ICANN may designate what we call the IVERO, or the Emergency Backend Registry Operator. So if you don't comply, let's say, with this table, or if a TLD is not in compliance with this table, and we are monitoring this on a weekly basis, on a rolling week basis, ICANN may have to designate what we call the IVERO. So this is the, let's say, boring contractual basis of what we are doing this. So now let me try to explain how the system works, which I think is the interesting part of this. So when the new utility program was being implemented on ICANN, we engaged Savix, the company that develops the Savix monitoring platform, in order to help us to develop this monitoring solution, right? So basically what the company did, Savix, they developed custom plugins and custom code just for what ICANN was trying to do. So we have an agreement with them, and they keep supporting the platform that they developed for us years ago. We have a proof node network, and that network consists of 40 proof nodes. We are covering all the ICANN regions, and we have agreements with those data centers to provide certain level requirements regarding the service that they provide. We have a network operating center. This network operating center is available to you, GTLD operators 24/7. And we have ICANN technical staff on call also on a 24/7 basis. So the design principles for these systems, the most important thing was to avoid false positives. Why? Because if we detect an issue, we will automatically call the registry operator and the legal contact and the primary contact. So basically, in the case of GTLDs and new GTLDs, we are calling sometimes the customers of the RSP or the backend registry operators. So imagine if we have a false positive and we are contacting the lawyer in the company that hires this company to provide the registry services, right? So the most important thing for us is to avoid false positives. And in these 4 or 5 years of operation, we have never had a false positive because, that's the most important thing for us. The other design principle that we have for this system is we try to reach the registry operator as soon as possible, and we try to provide some general guidance of what could be the issue that we are seeing in the system. So how it works, so basically we have these proof nodes around the world. We are monitoring all the TLDs, all the services, DNS, RDDS, and then the proof node sends all this information to a central data processor, and we have two. We have one in the West Coast and one in the East Coast. And this central data processor will take all this information from all these proof nodes and will decide if there is an issue or not with a specific service. So for example, for doing DNS test, we are doing a DNS test for every IP address named server that there is in the root for all GTLDs every minute. Normally what we do is we do a query for that domain name, zz-ICANN monitoring.tld. And if DNSSEC is supported, obviously we verify that the answer is correct, that the chain of trust from the root is valid. And if EPP is activated for that specific TLD, we support EPP in the system, then we do different DNS queries in order to understand how fast are you updating the DNS zone based from the EPP update. So this is basically for DNS what we are doing usually. You have examples of failures that we have found, right? Like no reply, or the name server is down, or server fail answers, or there is a broken chain of trust, or the signatures are invalid. We have found all kinds of issues. For RDDS or WHOIS, on the ICANN world, WHOIS is called RDDS. So for RDDS, we monitor WHOIS port 43 and WHOIS 80. Basically what we are doing is every 5 minutes we send a WHOIS query to the port 43 WHOIS and an HTTP request for web WHOIS. And these are just some few examples of what we normally find. You have DNSSEC issues sometimes trying to resolve WHOIS.nic.tld or invalid WHOIS query responses on port 43, or sometimes you are trying to monitor WHOIS port 80 and you find like an HTTP 500 error. It's really, really important to mention that all the recursive servers that we use on this infrastructure, they have DNSSEC enabled. So for example, if you have an issue with your DNS zone, and that issue is affecting WHOIS.nic.tld, which is the host name that we expect you to provide a WHOIS service, then we will see this as an issue, right? So we will tell you, hey, your WHOIS is failing, but in reality what is going on is that you have a DNSSEC issue with your zone. And it's also important to mention for those new TLDs on the room that the maximum TTL that we have configured or that our recursive server supports is 15 minutes. So we normally see the issues pretty fast, when they occur. So how this works, what is the workflow? So we have the monitoring system, and that system is basically doing this continuously monitoring. In the case of DNS, we need to detect 3 consecutive failing issues or cycles. And what is a failing cycle? So of the proof nodes that we have in the network, at a certain point in time, 51% of those nodes need to agree that something is failing. Once we have a 51% agreement that something is failing, we need to have at least 20 proof that are online and that we consider that the internet that they are receiving from the data center is a good quality internet, right? Because imagine if you're monitoring and the internet that is being provided to you as a customer, let's say on a certain country is bad, you will see the service of a TLD failing, but it's not the TLD that is failing, it's the connectivity that you have in your proof node. So we have an algorithm to detect if the quality of the IPv4 or IPv6 connection is good quality. And in the case of WHOIS or RDDS, we need to detect 2 consecutive failing cycles, and it's the same algorithm. 51% of those proof must agree that there is an issue. And in the case of RDDS, we only need 10 proof nodes to be online and with good internet connectivity. So once we find that there is an issue, then we send this information to an alerting machine that we call, it's a special piece of software that we develop. And basically that piece of software will make automated phone calls, automated emails, and we'll try to reach certain groups of persons based on the issue, right? So for example, if there is a DNS issue, we may contact the legal contact, primary contact, and the emergency contacts that we have for the TLD. If there is an RDDS issue, and depending on the threshold, we may also contact different departments. But normally what happens is, if you're a new TLD operator and something in your infrastructure is failing, you will receive a call from a machine saying, hey, you have reached X percentage of your allowance for that specific service. Please go and read your email and try to fix the issue as possible, right? We on the ICANN side, we will also receive that call. So someone that is on call is going to try to help you to solve the issue. And it has been really fun, I mean, this part, because, for example, sometimes, a few times, you call the emergency contact, and the answer is, well, you first explain, hey, I'm from ICANN, you have a TLD, the TLD is failing, and the answer is something like, what is a TLD, what is ICANN, why my company has a TLD, and why are you calling at 3 o'clock in the morning, right? But at the end of the day, we have always been able to find someone that has been able to help us fixing the issue. We have found really interesting things. For example, once we found, well, we helped the registry to find out that the DNSSEC signing appliance that they custom developed was generating bad signatures for a portion of the zone and only for certain periods of times. So you will see that TLD like going dark because of DNSSEC issues like for like 5 or 10 minutes on different periods of the day. I mean, it was really strange. It was a split brain. Yeah, it was a really nice bug. And so, and sometimes the answer from the TLD is, I don't believe you, please show me evidence that we're failing. Sometimes you need to explain that probably they are monitoring from within the network and the issues with the firewall, right? So when you monitor from the internet, from the outside network, then you don't, I mean, so we have found all kinds of issues over all these years trying to fix all these issues that we found. So how we monitor that the quality of IPv4 or IPv6 is healthy on a certain proof node? Well, every minute we send a query to the root servers, to all the root servers from the proof node, and if the response is valid and received within 250 milliseconds, then we consider that the internet quality is okay. We try different algorithms because you may understand that this is, I mean, it's really difficult to say, yeah, my IPv4 or IPv6 connection to the internet it's okay or it's well enough to do this. So this is the algorithm that we found that is the most appropriate for what we are doing, and it has been working all this time. If we see that the connectivity is not well enough for doing monitoring, we basically turn off automatically the proof node. So that's how the system works, and that's basically what we have been doing all these years. For the new TLDs or GTLDs in the room, we have an API and in pilot mode. So you can use this API to see what ICANN is seeing from the monitoring platform. So if you want to have access to this API, you can request access at any time and you will get all this information. And you can automate your system monitoring using this information also. And some statistics, I think this is the also fun part of this presentation. So in the market, in the GTLD space, there are 37 RSP, or registry service providers. These are the companies that basically provide the backend technical operation for the registry operators. So you may have, or you may see, oh, there are a lot of registry operators on the GTLD space. Yes, there are a lot of GTLD registry operators, a lot of probably small or large companies. But at the end of the day, we only have 37 companies that are providing the technical back-end services for those companies. So these are the 37 registry service providers. And in all these years, we have, well, of those 37, 11 have had at least one event that reached the Ibero threshold for that service. So the failure was large enough to be considered for an Ibero transition. And of those, so those are the 11, right? So we have had 27 service failures that reached the Ibero threshold, and it's important to mention that we have not declared one Ibero event yet, because after working with the TLD, we have came to the conclusion that we should allow the TLD to fix the issue, because doing the Ibero transition is going to be more harmful for the registrants than just letting the registry to fix the problem. So this means that 1.7% of all the new TLDs have reached an Ibero event for DNS or RDDF. And of the 37 RSPs, 32 have had at least one DNS service failure since 2014. So there are only 5 RSPs that have never had a DNS service failure in all these years. And I mean, the last statistics is really important because most of the DNS failures are related to DNSSEC. So you can understand that doing DNSSEC is hard because, I mean, these 37 companies are the companies with the most experience to manage DNSSEC, and they have issues. I mean, it's not easy. So over all these years, this is how the frequency of potential Ibero events during all these years. So you can see that is more or less constant. So every quarter you will have some events that could be considered for a potential Ibero transition. And this is, I mean, each color represents a different RSP. So you can see the different failures that reach an Ibero event for RSP. Obviously, all this information is anonymized, so this is only to show you how it works, I mean, what we're seeing. And these are the DNS failures over time. So you can see that also DNS failures are constant over all these years. And these statistics show you how different RSP have DNS failures over time. And it's also very constant. So that's it for the SLAM. I don't know if you have any questions.
Good morning. Michaela Naden for the record. Some of these statistics are a little bit disturbing, to put it mildly. And I love the way you're kind of saying that it's just DNSSEC related. What concerns me is if there's SLAs there and they're being breached constantly.
Well, not constantly, but I mean.
Well, here's the thing. There's been several TLDs who've migrated between backends. In one instance, the entire zone disappeared for about 8 hours. I didn't see any breaches. From our perspective as a registrar, that's completely unacceptable. It'd be one thing to have a minor blip that might affect a TLD for 5 or 10 minutes. That you can understand, but an entire zone disappearing for 8 hours or thereabouts is nutty, especially when it's a new TLD. And I have registry operators whinging and whining like little girls about why registrars aren't doing enough to push this, whereas I can look at .com, it's 100% stable, and I don't have to lose sleep over it. Yet well, you've got this here, and you don't seem to be enforcing the actual rules. This I find a little bit disturbing.
So when we detect an issue, we call the registry and we work with them to fix the issue. So sometimes you will see those glitches, but in reality someone is behind the scenes working with the registry to fix those issues, right? I mean, what ICANN has as the, let's say, mechanism to solve these issues if the issue is really large or bad is the event, right? And every time that we reach the event event, we have the executives and we have the technical, the technical persons, we are also there. And we are discussing if we should do an event or not. But in all these cases, what we have came to the conclusion is it's better to let the registry to fix the issue, because if we go the event, which is going to be the ultimate punishment, let's say, it's going to be harder or worse for the reasons. So what we have in our mind every time that we reach these thresholds is how to mitigate or how to to minimize the impact on the resistance. That's basically what we have been doing all these years. And believe me, compliance, they send the notices and the registry needs to come back and tell us, hey, we failed because of this and we are doing this to be sure that this never happens again. So there is a lot of work behind the scenes with the registries to be sure that they are fixing the issue that they had.
Yeah, but that's fine. But when you're looking at transition of TLDs between backends, then it becomes a case of pass the parcel, because you might have one DNS provider and two backends and two different contracted parties.
So every time
if the TLD is being sold, so the question there is who is responsible?
So every time that there is a transition between two backend registry operators, they need to submit, the registries, they submit a transition plan to ICANN. And from the technical perspective, we review the plan. And most of the time, we work with the registries to fix the plan, because sometimes the plan is going to create a DNS instability, right? So there is a lot of work behind to prevent this from happening, but sometimes it just happens.
We have about 5 minutes, and we have 4 people lined up at the microphone. So I'm going to shut the line now, or 5 people in the microphone, and please keep your comment or question short.
I have 2 short questions. One, the frequency of checks and the automated alerts. Who's responsible for checking the software and updating it? And is there any manual, like human touch to it? Because if there is something detected and the alert goes out, and as you said, you false positives before in the other presentation, I'm just wondering who checks that software. And the second question is, if the PKI or the minimum threshold is met, and you do the courtesy call, and heard the explanation just now, but is there a minimum time for correction or remedy? The mitigation things that you do is fine, but what is the minimum to actually have the TLDs? If it's happening at multiple TLDs, what's the minimum time for correction?
So regarding the questions, we have never had a false positive. So we trust the system. That's a really important data point. There is no manual verification. If we detect something, we contact everybody. And everybody means legal contacts, primary contacts, everybody. And this is an automatic verification. That's what is going. When we, ICANN staff, we receive the alert as you, the registry, and we receive the alert at the same time. At that point, we start working to understand the issue, like the details of the issue. So when we call you, we can provide you with more feedback or insight of what is going on. And most of the registries, they have been very receptive to our ideas or potential solutions for the issue. Regarding the time that you have to fix the issue, well, that's in the agreement, right? That's the emergency threshold. That's the time that you have to fix the issue. And if we work with you and at some point we decide that, that the best course of action is to just go to the zero, well, then that's going to be the case.
James Gannon. So following up on Michaela and Carrie-Anne's comment, first of all, within those 32 out of 37 and multiple cases, do you see many recurring within the same registry service provider, or is it pretty evenly distributed?
Both.
So, yeah, which was my expectation. So it seems like, we have the engineering piece, and there seems to be good incident response, and there seems to be a good way of managing that. But then it seems on the governance and the contractual compliance, something's not happening there. If we have 32 out of 37 experiencing failure events, then there really should be a governance process that's kicking in to stop these recurring. You know, we have the engineering experience to be able to help these registry service providers stop having these incidents when they happen, but there is also the follow-up piece that to my impression, seems to be missing. How do we make sure it doesn't happen again? Because if you have recurring things at a registry service provider level, and Michaela has given good examples of that, then there is a whole governance piece that is missing on prevention rather than response.
Well, you know, it's interesting because we normally ask for an after-action report, and in the after-action report, what we have noticed is these are different issues. I mean, it's not. I mean, the failure may be recurring on a TLD, but why it happens, it may be different between different events. So
we're getting really out of time, so I would like a quick answer to this question, and I would encourage the following discussion maybe happening over lunch.
Francisco Arias, from Technical Services, like Gustavo. Just very quickly on that regard, there is already a collaboration between the ICANN organization and the registries to try to find better mechanisms to improve the situation. There is the idea that at this moment we call it the RSP program. We are still exploring what's the best way, but we are trying to collaborate to find better ways to improve this situation. So in that regard, there is already an effort on the governance side, as was mentioned, to improve the situation. Just wanted to let everyone know that there is something right in this regard.
Thank you. Gustavo, thank you very much.
Thank you.
Next speaker.